This is my project, neural network optimization. So the purpose of my project is to basically make the most accurate model of a neural network that I possibly can. So here we see a neural network. So basically, you can just think of it as a function. You have an input and you'll get an output. And basically, when you create the neural network, it's pretty easy to create the input layer and the output layer. So if you're creating an image identifier, creating the input layer will just be like the pixels in your photo, and the output layer will just be like what are the possible outputs for your neural network. But here's the thing. We have this stuff in the middle, and what happens when we change the size of that hidden layer? Well, that's something I want to figure out for myself and see how does that affect the efficiency of our neural network. Training the network. So when we're training the network, wait, last slide. Okay. So here we see this mathematical operation, and this is just showing how one layer goes from one to the next. That's all it's saying. And when we get this value here, it gets run through a certain function. Now this function could be as simple as when x is positive, y is 1. When x is negative, y is 0. And sometimes that works well. But in certain cases, we need something that's better. So that's what I want to also check. So like, what's an activation function that I can use to make the most efficient neural network? Training the network. So when we're training the network, we're giving it data. We're giving it, like, for example, we're giving it like photos like this, cat. We're giving it labeled photos. So maybe we have an image of a cat, and it's labeled with the identifier cat. So we want our neural network to make a guess on the photo, whether this is a cat or something else. And at first it's going to be really bad, but it's going to get better over time. So when we're training our network, we need to have an adequate learning rate. Think about it like this. When you're like teaching a student something from a textbook, you don't just throw the whole textbook at the student. You have to have an adequate learning rate. That's the same thing with the neural network. We need to find the adequate learning rate. Backpropagation and gradient descent. So basically, this is how the neural network gets better over time. So these mathematical operations, if you've taken calculus, you'll know that this is just a derivative. That shows the slope of our neural network's error. So what we want is our neural network to minimize its error. That's what's happening right here. So you can think of this hill as like our neural network's error, and it's getting worse, or not worse, it's getting better and better over time, and it's reducing the error. So we want our neural network to be able to reduce its error as fast as possible. We want the error to be as low as possible. So there's a couple of ways we can achieve this. We can make it so that the neural network has an adequate learning rate. It's not too fast, otherwise it would just go from here to here, to here, to here. We don't want that to happen. We want to have an adequate learning rate that's not too fast or too slow. Testing the network. So when I'm testing the networks, here you see like a sample of my data. What's essentially happening is over time, these networks are reducing their error, and you can see this in the graph. So these three networks are here, and the yellow one is obviously the best one. So what you're seeing is each neural network has these constant factors. They all have the same architecture, they all have the same learning rate. The only thing that's different is the amount of steps it takes during training. So what I wanted to see is what are the proper steps that each neural network needs to take in order to achieve the lowest cost or the lowest inefficiency possible during training. So as you can see here, the yellow one is the best. And hopefully I will be able to do this for all my other factors that I've identified in this presentation. So this is just the first phase of my project. This could be data collection. After I've collected my data, what I want to do is be able to apply the factors that I've learned from data collection in a more practical settings to see what is the neural network that can perform the best. Thank you.